Who are you, miss? Can you help me? What is your name?
Alam.
Okay, thank you so much. Okay, now it's recording. We lost one part. Okay, now. Okay, what is the organization? 16 now, we are doing. Well, bring down x squared, bring down 6. 18, I move to the other side, always the same. And you put a box. And the box, remember the magic number. Magic number, that complete square. And what is the formula for the magic number? Well, the formula is b over 2 square. Who is b? Well, b is 6. 6 divided by 2 is 3. And 3 squared is 9. 3 squared, sorry, square. Square. So it's 3 squared and 9. And 9. You put 9 here and 9 here. And now, automatically, this is perfect square trinomial, and the factorization is only one parenthesis because they are two factors, but they are identical, twin brother. X plus 3. Because it's perfect square. That is intention. Now on the right hand side we have negative 9. Okay. Almost ready. After that, you apply square root. Square root here. And square root here. X plus 3 without square. And square root in those. And it's a plus and minus. And square root negative 9 is 3i. Therefore, finally, solve for x minus 3 plus or minus 3i. 3i. End the story. Any question? Any question? Any question? Super clear or super confusing? Come on. Opinions.
Clear.
Okay, good. I happy to hear that. Okay, let's move on to the 17 and 18. Okay, they are equation. Okay, I call quadratic in front. Look, 17 is z4 minus 5 c squared plus 6 equal to 0. Okay, specifically, this example is extremely easy because we can do that by factorization. So normally this kind of equation, remember how you identification get this quadratic from, because this exponent is twice this exponent. Therefore, one possibility to do that is, well, by factory, why not? In this case, it's easy. And the next no is c squared gets the square root of this guy. And the combination that open the door is 3 and 2, because 3 times 2 is 6, and 3 plus 2 is 5, and both negative. Boom. Okay? Now you separate into linear equation. Into linear, no. Into quadratic equation, look. And you separate, well, you isolate the z square like that. Likewise here and 2, and you apply square root. To say plus or minus radical 3. Here likewise is plus or minus, c is equal plus or minus radical 2. Entonces now the solution set is plus or minus radical 3 and plus or minus radical 2. It makes sense because this equation is polynomial equation. This is quadratic from, and also polynomial because the exponent is a whole number, no fraction, no decimal. Now the degree is 4, and we expect when you finish the solving 4 solutions. Okay, it's plus or minus 3 and plus or minus 2. This is one possibility to do that. Okay? It's clear or it's confusing? It's clear? Good. Remember, this is a review. To say we are doing too fast because we saw that. Okay, let me try. Next is hard. I know. 18. C to the 6th power minus 152 C to the cubic power plus 3,375 equal to 0. So I realize two things. Number one, it's a polynomial equation because the exponents are whole numbers, 6 and 3. Okay. I realize also that the degree of this equation is 6. Therefore, when you finish to do that, we obtain 6 solutions, including real solution or imaginary or complex solution. Okay, but I detecting one more detail. This is quadratic form because this exponent is twice this exponent. Entonces, that is the reason que I'm using the idea for the quadratic form. What is the idea behind quadratic form? Is convert this equation to quadratic equation. How? Well, doing substitution. So use substitution U, que is normally, you know, the variable. Okay, everyone using in the world to change the variable. You. I don't know why, but U is the most popular variable. Like a CQE. How do you get CQE? Because you take the smallest point, get 3. Therefore, U squared es obvio que es C6, que is exactly the same as this. Now, when you rewrite the equation, using the auxiliary variable que es U, this is U, but this is U squared. And now, magically, this is magic, science fiction, you convert from this equation, polynomial degree 6, to a new equation que es quadratic. Que is super easy, we solve using the quadratic formula. And end the story. The story, no, because we found the U value que is the intermediate solution, partial solution, and you restore again the Z variable que is the original. Okay. So now in that moment, I focus in the quadratic equation, okay. So I detecting that A is 1, B is negative 152, and C is 3,375. And you apply the quadratic formula. Minus B plus or minus square root B squared minus 4AC divided by 2A. Substitution. Who is B? Well, B is negative 152, and double minus become positive. Inside the square root always is the complicated part. 152 squared. Remember, everyone have, I suppose that everyone have scientific calculator, no? I say in this class it's mandatory using this. Well, A1 and C is 3,375. Okay. Divided by.
Professor, isn't the 152 inside the square root supposed to be negative?
Yes, you are right. I omit that because in my mind, you know, when you square a negative number, the answer is positive. But it's okay. You are right. 100% for you. Okay, now. I focus in the expression inside, that expression. And of course, I use in the calculator because it's too heavy by hand. 152 squared. Let's do it. 152 squared. In my calculator. Oh, it's 23,000. 104. Minus. Now multiplication. 4 multiplication by 1 is 4. Multiplication by 3,375 is 13. 13,500. Now when you're subtracting this quantity, okay, let's do it. 23 104. Wow, is positive 9,604. And now you apply square root of this. So square root of square root 9604 is 98. Wow, I like that. Okay, now you copy down 152 plus or minus 98 divided by 2. And you split in two parts, plus and minus. Minus. Sorry, minus. Okay. 152 plus 250. 250 divided by 2 is 125. I like that. And 152 minus 98 divided by 2 is 27. 27. Wait. Is 27. Yeah, the final answer is 27. I divided by 2 in my calculator. Okay. And this is the answer. No. But almost we finish. Because remember here we are doing that substitution. Okay, connecting z, que es my original variable, and u, que es this value is u value, this is u value. Okay, so now I split the paper into parts. I put for u equal 125 and for u equal 27. Over there. But who is u? Is c cubic. 125. And c cubic equal 27. Okay. In this moment, I have two new equations. But it's a polynomial equation, and the degree is 3. And since the degree is 3, you expect 3 solutions in this case. So now this is big mistake, big, if you try to find cubic root both sides, because you lost 2 solutions for each equation. Now the super fantastic way to do that is you move, for example, 125 to the other side. Okay, remember this is almost identical procedure. Okay, and now factorization. This binomial que I consider in my mind is the differences of cubic. Let me recall the formula. A cubic minus b cubic is equal a minus b, a squared plus ab plus b squared. This is the formula for the factorization this binomial, que obviously is the difference of cubic. So you open two parentheses, one short, one long, like y here. Entonces now cubic root z is z cube is z, and cubic root 125 fi, and minus here. Exactly, I did that part. And inside the trinomial, we have c squared, because it's this the first guy gets z squared. Look at the a squared, plus always plus multiplication both gets 5c plus b squared gets 25. Okay, let me try to do exactly the same idea in the second. The second is c minus 3. Where come from that 3, guys? Cubic root 27 is 3. In that case, cubic root 125 fi, no? Okay. Entonces, c squared plus 3z plus 9. Where come from this 9? Is b squared. And who is b in this part? Is 3. 3 squared, 9. So you separate in this linear equation, okay, by the way, the answer is 5. And we have another quadratic equation. You see, bueno, professor, but what is the reason that you don't factorization this trinomial? And the reason is clear, because this factor, I guarantee you 100%, is prime. Prime means it's impossible to factorization. Why? Because the solutions are complex. I guarantee you 100%. This always happens in the difference of cubic. Okay, so now I can solve it. Of course you can, using the quadratic formula, A, B, C. A is 1, B is 5, and C is 25. Okay, minus B plus or minus square root B squared minus 4AC divided by 2A. And our specific example is minus 5 plus or minus square root 5 squared minus 4 multiplication by 1 multiplication by 25 divided by 2 times 1. Let's make a zoom to see that part more clear. 5 squared, 25. Minus 4 times 1 is 4 times 25 is 100, 100. And subtraction is minus 75. And the square root 1 negative 75, you see it's imaginary, right? It's I something, square root 75. But 75, let me try to bring down, is 3 and 25. So when you apply square root, it's obvious at least that part is 5, because I know that square root 25 is 5. Then the answer is 5i. That this 5 go outside the root and stay 3. Okay, this is complex solution. And the complex solution you can write in standard like that, negative 5 plus or minus 5i radical 3 divided by 2. Wow, nice. In total, so far we have 3 solutions, but we need 6 solutions because the degree of the original equation is 6. But okay, the other 3 solutions is doing exactly the same here. In this case, C minus 3 is equal to 0. That means that C is 3. This is my next solution. And here exactly the same. C squared plus 3C plus 9. Don't try to do factorization here. It's impossible. I guarantee you. But quadratic equation always. A is 1, B is 3, and C is 9. Entonces, minus 3 plus or minus, the formula is here. I don't want to copy again, no? Minus 3 square root 3 squared minus 4 multiplication by 1 multiplication by 9 divided by 2 times 1. The part inside the radical is 3 is 9. This is 9 minus 36. Entonces 9 minus 36 is 27, negative 27. And the square root of negative 27 is I square root positive 27. And 27, you know, is 3 and 9. And the square root 9 is 3. Automatically, I saw that we have 1 3 outside. 3i radical 3. Wow. This 3 and this 3 stay inside the radical, and this 3 is the new 3 that go outside the radical. So far, my answer is minus 3 plus or minus 3i radical 3 divided by 2. In total, let me summarize how many solutions. Well, you have 1 solution, look, real. Another solution here, real. And 2 complex here, and 2 complex here. So total 1, 2 real, 3, 4 complex, 5, 6 complex in total. I know it's too long. This is not the point. The point is you understand very well the idea behind this. This is equation polynomial degree 6. We expect 6 solution, but it's quadratic in front. So I take advantage of quadratic in front. Quadratic in front, using substitution you convert to quadratic. Entonces now you solve the quadratic, you find the partial answer u, and using the combination with the idea, the formula for the substitution, you obtain, in this case, 2 new equation of the degree 3. Polynomial also can you solve it using the factorization. As always happen, no? Factorization is the key idea for the any question, guy? Boom. Wow, no good. Okay. Let's continue. Let's practice a little bit now. Radical equation. 11 and 12. For example, square root x plus a plus 12 outside equal x. This is the original. This is radical equation. And remember the idea, the basic idea, the key idea for the solving the radical. You first of all isolate the radical. You move 12 to the right hand side. Now ready to square. X plus a without radical is equal x plus minus 12 times itself. You FOIL. Here, x squared minus 12 again, and plus 144, que es 12 times 12. Now why not combine like term? This is 24 plus 144. Okay, at this moment I manipulate my original ugly radical equation. You obtain in the middle of the process one quadratic equation. So this quadratic equation is not already expressing standard. I need to express the standard. So I propose you move everything to the one side, maybe to the right or to the left. I prefer to the right because we have 2 only in the left. So I move minus x minus a. And here we have nothing, and nothing is there. Now ready to combine, enter. X squared minus 24 and negative 1 together is 25. Plus 144 minus a, 136. Okay. Now to feel more comfortable, you interchange this guy. Okay, here I have the quadratic equation. Wow. By factorization is crazy, but by quadratic formula is always easy. Well, relatively easy, no? Using the calculator, of course. 1, negative 25, and 136. I plug it in. I don't want to copy the formula again, guys. It's 25 get minus b, plus and minus square root negative 25 squared minus 4 multiplication by 1 multiplication by 136 divided by 2 times 1. So I put in my calculator 25 squared is 625, I guess so. Let me check it just in case in the calculator. 25 power 2, exactly 625 minus something. 136 times 4 is 544. Now subtraction both is 81. Wow, nice. I like because 81 is perfect square number and the answer is 9. Therefore, we have so far 25 plus or minus 9 divided by 2. Separate two pieces. The positive piece, the negative piece. It's 25 plus 9 divided by 2 and 25 minus 9 divided by 2. 25 plus 9 is 34. 34 divided by 2 is 17. Okay, I enclose this because it's important. Now 25 minus 6 is 16. 16 divided by 2 is 8. It's also important. But that's it, no. This is a typical mistake of the student. I'm warning you because you don't finish. And this equation, mandatory, you need to checking. See, I don't see the checking part in the test. I put 0 in that equation. Okay? Because this is a part of the game. Important part. Because 17 and 8 maybe work or maybe doesn't work in the original equation. So I need to check it for both. Checking for x equal 8 or 17 first. And checking for x equal 8. Secondly. Entonces the square root 17 plus 8 plus 12 outside the radical should be 17. Likewise, 8 plus 8 plus 12 should be 8. I need to check in this statement if it's true or no. It's obvious that the first is true because it's 25, square root 25 is 5, and 5 plus 12 is 17. No problem. True. That solution is good. Now this is 16. Square root 16 is 4. And 4 plus 12 never is 8. This is false. That means the solution is wrong. And the only solution we have this equation is 17. Solution set. 17. End the story. Okay, the checking part is extremely important and the radical equation is mandatory. So basically in algebra, we can checking any solution, but not mandatory. The checking is only if you want verify that you are doing well or no. So you plug it in the original, the equation that you get is too consuming time, I know. It's too long process, but it's not strictly mandatory. However, in the radical, yes, it's mandatory. Because the thing that happens is that the manipulation for the equation in one moment of the algebra, the new equation is not exactly 100 equivalent to the original. Now, sometimes, not always, but I promise in the test, you see this problem. Okay, you need to verify. You need to verify. Okay, number 20 is similar, exactly the same. You isolate the radical as the first step. Move everything to the other side. And it's the most important moment, crucial moment. You square both sides because this square allow me eliminate the radical. And you foil like here again. X minus 8, x minus 8. X squared minus 8x minus 8 again plus 64. We combine lighter x squared minus 16 plus 64. Well, I try to express it. My equation is standard. I forgot x here because 8 minus 8 and minus 8 together give me minus 16. I copy that. Okay, and move minus x and move minus 4. Okay, so we have x squared minus 17 plus 60 because 64 minus 4 is 60. To feel more comfortable, I interchange. I put x squared minus 17x plus 60 equal to 0. Okay, in this particular example, you can solve it by quadratic formula again. But no, because I realize that by factorization is relatively easy. Remember my recommendation, no? When you see the combination that open the door, you don't need to go to the long way, get the quadratic equation. No? The quadratic equation is safe. Always you get the answer, but the shortcut is the factorization when it's possible, because sometimes no, it's impossible. In this case, the possibility is 12 and 5, because I know that 12 times 5 is 60 and 12 plus 5 is 17. Negative both. Then we have two solutions. The first solution is 12, and the second solution is 5. Nice. But I need to verify in the original equation both solutions in order to verify see is correct or not the statement. Check. 4 x equal 12 and check 4 x equal 5. Guys, I explain step by step. I want to see similar solution and your answer. Okay, remember, si you don't show me the checking, 0 for you. Okay, 0, 0,0, nothing for you. The checking is extremely important. It's mandatory in this kind of equation. But it's easy, it's just arithmetic. Look, it's square root 12 plus 4 plus 8 should be 12. You prove this. Claim that. Square root 5 plus 4 plus 8 should be 8. Should be 5, sorry. Get the x back. In this case, 16. Square root 16 is 4, and 4 plus 8 is 12. Yes, true. Therefore, 12 is okay. This is 9. Square root 9 is 3, and 3 plus 8 is 11, no 5. This is completely false. Now the solution is wrong, and the solution is 12. Solution set. It's clear? Opinion. I make a review exactly the thing you can see in the test, right? No, different number, of course, but same idea. Any question? Answer me. Clear or confusing? Come on. Clear. Okay, Nico says it's clear. Okay. Jasmine say get clear. David say get clear. Okay, I believe you. Clear, Angelica Jimenez. Okay. Let's move on to the equation que contain absolute value. Equation and inequality que contain absolute value. Okay. Clear. Okay. Dalida. Say it's clear. Okay. I warn you again. Some students que don't pay attention, don't automatically remove the bar. So copy that. 5x plus 2 equal 8. And this bar is nothing. Okay? 0 for you. No. This is completely wrong. When I say that, 0 point, because it's conceptual. So now, what is the equivalent expression? Well, you copy 5x plus 2 equal 8, but you copy also 5x plus 2 equal negative 8. So on the right hand side, you put positive and negative, and the left hand side, you remove the bar and you copy twice, and you form two equations. And you solve it one by one. That's it. 5x is equal a minus 2. A minus 2 is 6 divided by 5. X is equal 6 over 5. This is my first solution. My second solution is 5x is equal minus 8 minus 2 que es negative 10. Divided by 5, both sides. X is equal minus 2. The solution of this equation is, look, solution set for this equation is 6/5, negative 2. Guys, it doesn't matter the order. The order is not important. So the student write like that, negative 2, 6/5 is the same solution, right? And when you're talking about set, the order is not important. Okay, this is the equation. So now, okay, be careful. When the right hand side is positive number, we expect two solutions. When the right hand side, like a 22, is negative, automatically you say no solution. We have no solution because right hand side is negative, and this is a contradiction because absolute value always give me a positive number, and positive number is equal to negative number. No. It is impossible. So when you see right hand side negative, and in the left hand side we have absolute value expression, this is a contradiction. Okay, and zero, no, zero, yes, zero is possible, but you have only one solution. One solution. This is two solution. It's a two solution like that. One solution. How? What is the one solution? Well, easy. You remove the bar. In this case, yes, I accept. So you see zero, and so you can do it like that. Remove the bar. I don't care that bar. Put it equal to 0, and that's it. What is the reason you cannot two solutions? Because 0 have no sign. Positive 0 and negative 0, 0 have no sense. And there's another number, 8. Oh yes, positive 8 and negative 8. But 0 is just 0. Negative 0 and positive 0 is impossible. We have only 0 que es in the middle of the number line. And you solve this elementary equation, and that's it. 3w is equal minus 8 divided by 3. W is equal minus 8 over 3. Done. Final answer. This is the answer for this equation. One solution. Negative, no solution. Positive, two solutions. Separate positive and negative. 0, one solution. Everything is clear or confusing? Everything is clear or confusing?
It's clear.
Excellent. I know. Okay. Now, let's move on to the inequality, que is also easy. Let me show you. Okay, inequality now. The first, remember, you have two possibilities for the inequality. Less than or greater than. Let's do it simultaneously because I want you see the differences. Less than 30. And the second one is 2x plus 8 greater than 12. Okay, focus, guys. Okay, remember, any expression que contain actual value, this or this, represent distance from the specific point. And when you see less than, it's because it's near. It's just near is the only one interval. So when immediately I see that, I expect in the solution one interval. Okay? In this case, no. Why no? Because this is too far. It says a weight. So therefore, it's two interval. When you write the solution of this, you see in this case a bracket because it's equal. Something comma something. This is the answer I expect. In this case, no. In this case, maybe parenthesis two parentheses, something, comma, something, something, comma, something, and union in between both, two intervals. So immediately when I grade that, I see, can you put here two intervals, or here one interval, I put 0. 0 for you, okay? I warning, because every day happen that when I grade test number 1 in college algebra, okay, it's easy for me, I do it too fast. I see, oh, it's completely wrong. Because I don't understand. No, professor, because I did one part. No. Conceptually, you are wrong. Therefore, 0 for you. So what is the equivalence? The equivalence is easy. Look, you copy only one compound inequality. Like that. You remove the bar, actually. And you put less than or equal 30 and greater than or equal minus 30. Okay? And you solve this compound inequality. And only one piece. Because you consider it gets 3-part inequality. Subtracting 12, solve for x. Subtracting 12. Column by column, this is minus 42. This is 5x, this is cancel out, that was the intention. And this is 18, no? 18. By 5. Whole thing. And 5 is a positive number, therefore, this inequality design stays the same, because when you divide it by positive, doesn't change. However, this is 42 over 5, and 18 over 5. Okay, and like that, no, because in the test I specify, I want the answer in interval notation. And remember, the interval notation es the notation que we put a bracket or paréntesis, ¿no? Entonces you put a lower bound, que es negative 42 over 5 first, comma, upper 18 over 5, and in this case, bracket, because the bracket indicates also, can include the endpoint. How do you know it can include? Because we have equal here. Si we have no equal here, suppose que we have no equal here, suppose que I erase equal here, the answer is the same except que es a paréntesis. Now, Juan, paréntesis. Okay? But no. This is not my problem. My problem was equal and bracket. Do you get the idea? Clear or not clear? Clear or not clear? And one piece, one interval. And the second, no, definitely no. Because okay, Victor, pijamizar. And the second, no. And the second, two piece, because it's too far. So now you copy two times the expression inside the bar, without bar. And this is greater than 12. This will look like similar to this without bar, but this is less than negative 12. This is the new thing. And we connect it by OR. In this moment, we have compound inequality. Well, this actually was compound inequality, but a three part. In this case, compound also is two inequality connected by OR. And remember, the idea for behind the OR is union, put together without repetition. Okay, you solve it separately, both. Entonces, you interpret it like two different problems. 2x greater than 12 minus 8 is 4 by 2 is 2 greater than 2. This is one piece of the solution. The second piece is 2x less than minus 12 minus 8. 2x less than minus 20 by 2 and negative 10. So now, well, okay. So professor said, well, how you express that? Well, okay. You can connect this and this together by OR using this conjunction, no? or. But no, because they want interval notation one more time. So to understand a little bit more clear, interval notation, in my opinion, is you have the rule, you have the number line, look, boom, you have the number line, and this number line, we have here infinity positive, infinity negative, 0 in the middle, 1, 2, and negative 10 I suppose get here. So this statement, this is this interval. Of course, no include 2, no, because I don't see equal sign here, no equal sign. Oh, no equal sign. And this interval is this. And again, no include 10, negative 10. No. So what is my final answer? Final answer. What are my final answer? Two pieces. Is from negative infinity, comma, negative 10, parenthesis, union, 2, infinity. End story. Final answer. Any question? Any question? We are the best in Miami-Dade College or no? We are or no? Come on, the enthusiasta student. Like, okay, Angelica say, yes, we have no problem to get A in this class. Well, not so far, in the chapter 1 at least, no? Okay, another opinion. Another opinion. Guys, remember, the key idea in mathematics is practice. Practice. And the thing to practice is doing the lab online. Okay? Okay, so we take advantage the time that we have to start a chapter 2. We finish the chapter 1 today. I grade the test tomorrow. Now we start chapter 2. It's a little bit complicated, in my opinion. Some people fail the test 2. I don't know why. Okay, the chapter 2, the first topic we are studying is the distance. Look, the distance midpoint formulas. Midpoint formulas. Distance and midpoint formula. Okay. Let me try to recall something. Okay, we have the rectangular coordinate system. Our famous rectangular coordinate system. I want to recall quickly, of course. Plot different point inside. Plot different point. Plot different point on the rectangular coordinate system. Suppose the first one, 5,4. Point A. 5,4. Remember, 5 represents the x component. So the first number is the x component, and the second number is the y component. 5,4 A here. Over there. 5,4. 1, 2, 3, 4. Here, over there. This is the point A. By the way, the location of this point is in the first quadrant. Because the first quadrant is that region. How you identify that region? Because when the x is positive and y is positive both simultaneously, so 5 is positive, 4 is positive, this lies in the first quadrant. Okay, another point. Suppose the point B is the point -3,4. Let me plot that. Negative 3 here, comma 4 is here. Over there, huh? 3, comma 4. Okay, 1, 2, 3, 4. Yes. This is the point B. And the point B lie in the second quadrant. This region is the second quadrant. Why the second quadrant? Because x component is negative, but y component is positive. Look, x component is negative 3, and y component is positive 4. This is second quadrant. Okay, point C. Point C is the point negative 3, comma negative 5. Okay, I plot that. Negative 3 again here, and negative 5 here. I plot that. This is the point C. The point C. And the point C lie in the third quadrant. Okay, it's this region. How you identification get third quadrant? Because x is negative and y is also negative. Look, both are negative. This is the third quadrant. Third quadrant. One more point. The point D. The point D is suppose 4, negative 4. Suppose hypothetically 4, negative 4, positive 4, and negative 4, negative 1, negative 2, negative 3, negative 4, 4,8 here. The point D. And the point D lie in the fourth quadrant. In the fourth quadrant, let me use in another color, maybe red. This region is the fourth quadrant, and to say identify the fourth quadrant because x is positive, but y is negative. Okay, this is the fourth quadrant. And that's it. No, we have more scenarios. What is scenario? Well, you have, for example, the point E. The point E, okay, is the point, for example, I don't know, let me try to find negative 6,0. Entonces, the component x is negative 6, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6,0 here. This is the point E. Okay, this point lie on x-axis. Not belong to any specific quadrant because the axis is the boundary between the quadrant. And the point, for example, F is the point 0,7. When you plot that point, it always too far here, but it's on the y-axis. No belong to any quadrant. Okay, super clear or super confusing? I suppose you know very well this. Yes or no? Exactly. Now, let's move on to the formula. In that topic, we're working with two formulas. What formula? Well, the distance formula and the midpoint formula. Let me explain in detail that. Again, I try to bring one rectangular coordinate system. Okay, another. Okay, here. Suppose we have hypothetically 2 points. Hypothetically, I suppose we have 2 points, P1, P2. Suppose P1 here, P1, point 1. And suppose P2, why not here, P2. Okay, what is my goal? My goal is find the distance. So the distance is you connecting this point by the segment line, and the length of this segment line is the distance between P1, P2 segment. Okay, so in this case, well, I don't care the number. I call in general, you know, I call in general. This is x1, and this is y1 in general, and this is x2, and this is y2 in general. Therefore, this segment, let me use in blue color, is x2 minus x1. The difference, the subtraction. And this segment, let me use in another color, is y2 minus y1. You're subtracting the y component. And you have now here a triangle. By the way, it's a right triangle, 90 degrees. And we're using Pythagorean Theorem. Ya know que the hypotenuse, que es D, en red color, is a square root of the differences x2 minus x1 square plus y2 minus y1 square. Okay, and this is my famous formula, distance formula. Don't worry because we practice example now. Basically, it's a little bit complicated, but no, it's you subtracting separately the x component of the point and the y component of the point. You square both. You adding, plus, and finally square root. And midpoint. This is the distance formula. Distance formula. And the midpoint, what is the midpoint? The midpoint is the point in the middle. In the middle of what? Of this segment. So this segment, que es red color, is the segment que connecting P1 and P2. However, I need to find midpoint. I call M midpoint. The point that you split in two equal parts. And what is the formula? The formula is easy. The formula is just the average. Average. So midpoint is a point. Like any point on the rectangular coordinate system xy have two components, x sub m, y sub n. I call like that because the subscript m indicate us midpoint. Entonces x of the midpoint is the average, is x1 plus x2 divided by 2, and y of the midpoint is y1 plus y2 divided by 2. Wow. And this is my formula for the midpoint. Midpoint formulas. Okay, actually it's two, no? Because we have two components. Midpoint formula. Any question? Let's do an example. I bring two examples. Very interesting example. One easy, one piece okay. Another a little bit more complicated. Any question? I know you are super familiar with the plotting the point on the rectangular coordinate system, number one, and number two, determine what quadrant, in which quadrant lie, and secondly, the formulas of the distance formula and midpoint formula. Now, let's see now application. I bring two problems. One example one, super easy. My example one always is easy, kindergarten example, and two is a little bit hard. Example one is 2 points given. The point is given. This is find the distance, and midpoint, both formula we are using. Okay, of the points, negative 4,0 is the first one, and 4,6 is the second. Okay? Done. I highly recommend, okay, when you face that problem, you plot this point on the rectangular coordinate system. I highly recommend. Not exactly mandatory, but I like to visualize. Entonces now you compare your computations and the thing you see using your eyes and your common sense. I plot the first point. I want to call A equal and B equal. Negative 4,0 is located here, I suppose. This is A. 1, negative 1, negative 2, negative 3, negative 4. And 4,6 is 4, 6. There you go here. B. 4,6. And we're connecting, using the rule, we're connecting that point with the segment line. Let me try to do my best. Okay, okay, you're connecting. I prefer red color, I don't know why. There you go. And this is the distance I want to find, the length of this segment. It's doing mathematically. Distance formula. Distance formula is distance between A and B segment is a square root. You apply the formula. Some students prefer doing systematic using the formula. You call, for example, this is x1, this is y1, this is x2, this is y2. So now you square, you have two expressions square. This is the formula. And in the first, you're subtracting the x. Entonces, es x2 que es 4, look at that, 4, minus 4. Okay, this minus is the minus of the formula. Let me write the formula one more time. Look, x2 minus x1 square and y2 minus y1 square. So you just replace, you just plug it in, who is x2? Identification. Bueno, I call whatever, B and A. I call B is 2 and A is 1 or whatever. So you call A is 1 is 2 and B is 1. Doesn't matter. The answer doesn't change. Now 4 minus 4, because that minus is this minus, no? And this negative 4 is the value for this component in the A point, que es negative 4. And y2 is 6. Look, minus the formula and 0. No y1. Okay, now you compute that. Double negative become positive. So actually it's 4 plus 4. 4 plus 4. And 4 plus 4 is 8. A squared. And the 6 minus 0 is 6 and 6 squared. And this is a 64. And this is 36. And this is 100. And the square root of 100 is 10. And the square root of 100 is 10. And 10 is that distance. This is a linear unit because the distance, no? Linear unit is the distance. Okay. And one shortcut I like so much, is not necessarily using the formula. So you open the square root, you know that we have inside the square root 2 parentheses square. And you're subtracting the component. Look, point B, the component x is positive 4. And the component x and point A is negative 4. So what is the distance between positive 4 and negative 4? What is the distance? It's obvious that the distance is 8. Because look, 1, 2, 3, 4, 5, 6, 7, 8. You put 8 here. Bam. What is the distance in y component, vertical, in between the point A and point B? Well. And vertical component is that distance, 1, 2, 3, 4, 5, and 6. And you get the same result doing it that way. So basically, subtracting the x component, you can see graphically. Oh, no. Oh, analytically, either way, the way you prefer, the way you see much better. You learning much better visual. Graphic is easier. And using the common sense, what about midpoint? What about midpoint? I suppose the midpoint is around that point, right? Or no? Ese is my midpoint. Using my eyes, no? In my common sense, midpoint. Pero no, okay. No, I need to compute. Midpoint is the sum, x1 plus x2 divided by 2. And y1, y sub m is y1 plus y2 divided by 2, no? Okay, in our example, x1 is -4 plus x2 is +4 divided by 2. -4 plus 4 is 0 and divided by 2 is 0. Is 0, is 0, is 0. And what about y? And y is y1 is 0 and y2 is 6 divided by 2. 0 plus 6 is 6 and 6 divided by 2 is 3. Exactly the point that we expect using my common sense is 0,3 is the midpoint. This is my midpoint. 0,3 is the midpoint. And the length of this segment is 10. We compute it here. Look at that. Here. 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 10. This segment is 10. Any question, guys? Do you see that? Clear or confusing? Come on, go ahead. I'm waiting for you.
It's clear.
Okay. Let's complicate a little bit because I saw this is too easy. Too easy. No. I want to complicate a little bit. Okay, in this case, in this new example, we have no 2 points. We have 3 points. A little bit more complicated. Suppose we have 3 points. Example 2 now. Example 2. 2 points is A point is the point -2,1. We have B point. B point is 2,3. And C point is 3,1. Okay. Entonces now the job is number 1 step A, plot the point. Plot each point on the rectangular que no existe, ¿no? And when you plot ABC, you format and form a triangle. A triangle ABC. Let's use this notation of the geometry. B point. So now find the distance. Find distance. What distance? Distance in between A and B, comma, distance in between B and C, and distance between A and C. 3 distance, no? Because we have 3 sides. You have to find 3 distance. Number C is verify that the triangle ABC is right triangle. Or no? How do you verify that? Well, suppose that you have right triangle, by definition is one triangle like that. That corner, at least one corner is 90 degrees. And when this situation happens, we have hypotenuse and we have 2 legs. Let me call CAB, much better. This is CAB. 2 legs and hypotenuse. So the relationship is Pythagoras. C squared is equal A squared plus B squared. Boom. You prove this. No is looking. Remember, geometry, you don't prove anything because I believe. No, you believe, no. You prove mathematically this Pythagorean relationship. See this Pythagorean relationship work. Entonces, this is right triangle. Otherwise, no. Now, finally, one more question is the find the area. Find the area. Find the area. Area of what? Of the triangle ABC. Of the triangle. Okay, let's do it. And what is the formula? Let me record the formula for the triangle. form area of the triangle is 1/2 the base multiplication high, always. Okay. By particular example in which you have exactly a right triangle like that, it's 90 degrees here. In the best scenario, can you prove que this statement is true? Entonces now it's easy because you suppose that this is the base. This is the base. And this is the high. Okay, and your multiplication. Okay, you take the left like a high. You have 3 distance in your hand. 3 distance. You take the 2 smallest distance, is the left, and multiplication each other and divide by 2. And that's it. And you find the area of the triangle. Super. No big deal. So what should I do? Well, as always, plot. Plot. I need the rectangular coordinate system. I need the rectangular coordinate system. I have that. Okay. I plot the point. I plot the point. Okay. Enlarge. Go ahead. Any question? Go ahead.
No.
Okay.
A, B, and
A and B what?
Okay. Point A will be in the third quadrant.
No, in the second.
Oh, in the second quadrant?
Yeah, absolutely. Look, Jasmine. -2,1. -2 in X and 1 here. Boom. This is A. Yes or no? This is second. And what about B? 2,3.
Quadrant 1.
Quadrant 1. Okay. 2,3. You're right. Quadrant 1. This is B, no? And what about C? 3,1.
Quadrant 1.
Exactly. Quadrant 1. This is my C point. Okay. Are we connecting? We connecting. We have, oh, no, let me use the rule. We connecting. Using the rule. Oh, let me see. Okay. We connecting. Okay. We have here one segment, AB. We have another segment, is in this case by coincidence, is completely horizontal because the Y component of the A and C is the same as 1. It's a coincidence. Not always happen, but in this case happen, no? And finally, we connecting B and C. Okay. Let me try. Boom. Almost. I get it. Almost. This is my famous triangle. And this famous triangle, I need to prove. Boof. No good. A ver. Eso, bueno. This is my famous triangle, right? So I need to prove. What do you think about the hypothesis of the rectangle? Is logical or no? Right triangle. Is logical or no? Or is illogical? What do you think? Somebody have
to be illogical because
it's illogical.
It can be the triangle may not be a right triangle with the with plots pointed.
You say yes, it's possible or no?
It can be possible depending on where the plots are, where the points are plotted.
Okay, good point. Jasmine said it's possible. Let's do it, Jasmine. Well, first of all, 3, 4, 5 is the right triangle. But no only 3, 4, 5, coño. O sea, they are another combination. Okay, let's do it. Okay, I did that. I did the first question. Yes or no? Boom, I did that. Now, the second question is determine the distance. I need to find the distance AB. I need to find the distance BC. And I need to find the distance AC. Okay, one by one. Distance formula, square root. Square root. Square. Entonces, in between A and B, you subtracting that component, X component. Look. X component is this and this, no? Okay, X component is, what is the distance between -2 and +2? I suppose it's 4, right? Do you see que 4? And what is the distance between 1 and 3? And the X and the Y component is in the 1 and 3. Es 2, no? Doesn't matter. You're subtracting mentally. But you subtract 1 minus 3 or 3 minus 1. Either way. Because I don't care if it's positive or negative. Es 2. Entonces es, look, this is 16. And this is 4. And this is 20. Boom. It's the answer. Radical 20. You can simplification? Of course you can. But no. For a moment, leave it like that. I prefer. You understand the reason after. BC. Do you follow me? BC is the distance between now the component X and B and the component C. What is the distance between 3 and 2? It's 1. You subtracting 2 minus 3 or 3 minus 2. It doesn't matter. I like subtracting the big number minus the small number, right? 3 minus 2 is 1. And what is the distance Y component? Is the distance between this 3 and 1 is 2. That's 2. And 1 squared is 1. And 2 squared is 4. And 4 and 1 together is 5. So actually the answer is radical 5. I'll leave it like that. That distance was radical 20. That distance gets smaller, I guess so, is radical 5. And that distance, that distance is super easy because it's horizontal segment. But okay, don't worry. Let's do it now. The distance between A and C. A and C is, what is the distance between 3 and -2? I suppose it's 5. Yes or no? Look, 1, 2, 3, 4, and 5. It's obvious que 5. 5 squared. And the distance in the Y component is 0 because 1 and 1 is the same value, and we're subtracting 1 minus 1 is 0. Entonces now it's 5 squared, que es 25, and the square root 25 is 5. That distance is 5. Make sense or no? Everyone follow me, or you are totally confusing? You are confusing? Come on. Opinion, guys. Hey, somebody change the background. Okay. I don't like this background. Okay. Again, I am in the forest. Let me see how you change that. I have no idea. Well, okay. Okay, everyone follow me so far? Do you understand where I come from this distance? It's clear or it's confusing? Now, how we prove that the triangle is right or no? How you prove that the triangle is right or not? Well, using the Pythagorean Theorem. What is the hypothetical hypotenuse? We have 3 distances, radical 20, radical phi and phi. What is the hypothetical hypotenuse? What is the bigger? What is the bigger? Answer me. What is the bigger? What is the bigger? Radical 20 is the bigger, or is radical phi or fi? What is the bigger? Fi. Alan say fi, professor. Because remember, where come from that phi was square root 25. Do you remember that, right? If you square, and you adding this, should be claim that equal this. This is 20. This is 5. This is 25. 25 equal 25. Okay, this is true. Therefore, the conclusion is yes, it is right triangle. Okay, this is right. It's right triangle. This guy is right triangle. Pero professor, I don't see. In my mind, this is I cannot see. It's right. What is the corner? What is the corner that is 90 degrees? A corner, B corner, or C corner? What is the corner that is 90 degrees? A corner, A, B, of course, because it's the opposite. Look, it's the opposite to this. Get the hypotenuse. This corner is 90 degrees. We prove mathematically like that. Boom. That corner is 90 degrees. Super. Now, finally, we find the area. What area? This area. The area is the surface enclosed by this segment. The area of this. Okay, let's do it. What is the formula for the area? Here is the formula. Area is equal to 1/2 multiplication the base multiplication by the height. But in this case, particular example, okay, we have a right triangle. We use on the base and the height for the two smaller. So basically, multiplication radical 20, que es the one guy que I suppose hypothetical, get the base. Si you don't see, you rotate your head. Okay, entonces now this radical 20 is the base, and radical phi is the height, or radical phi is the height, is the base, and radical 20 is the height. It doesn't matter. This is totally relative. And if you put together, get 1/2, and this is square root 100, no? Because 20 times phi, you put together this radical, and square root 110 divided by 2 is phi. Fi what? 1/5 square unit, you know? Square unit. I don't know exactly what unit we're using in the rectangular coordinate system, si es centimeter, or es inch, or es feet, or es mile, or es meter, but it's unit. Square unit because it's surface. Any question, guy? Clear or no? Do you understand very well distance formula? And the application for the distance formula? Okay. Super. Now, one fantastic application of the distance formula is using for describe somehow a circle. Now the topic now is circle. Okay, suppose we have no time to finish circle. We continue next time circle in detail. Circle. What is a circle by definition? Well, a circle by definition is a set of the point on the rectangular coordinate system x, y. Set of the point x, y such that are a fixed distance, que normally is called radio. Normally we use this letter. Okay, this fixed distance is a radio. Radius. Okay, normally we denote by the letter R. From a fixed point, que by the way is the center, que normally the notation que we use for the center at the point is two components, ¿no? Entonces the component for the center normally is called h, k, sorry. Okay, entonces what is the idea? Graphically, to understand. One picture is much better, blah, 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 1,000 words. You have center, it's a point, boom, h, k. And we have distance, is r, it's the radius. And we get the point, is x, y, is the point on the circle. Basically, the circle is the set of the point, okay, that, nice, it's a circle. Now, r fixed distance, always, the distance is the same at any point. Suppose you select another point, another x, y. And the distance is the same, it's the radius. Okay, and the fixed point is the center. Okay, that's my goal. My goal is now quickly find the equation for the circle. Equation of circle using distance formula. Okay, so now distance formula is square root. When we have center here, we have one arbitrary point on the circle. So we have find the distance and between. Let me see. Let me erase that part. Okay, it's distance between center. It's a center C, center, and arbitrary point I want to call P. CP segment is square root. You have to square. Okay, and the point x1, I call this x1, y1, I call x2, y2. Entonces x1 is just x, and x2 is h, and y1 is y, and y2 is k. And this distance, I know, que es the famous radius, little r. If you square both sides, of this equation, x minus h squared plus y minus k squared equal r squared. Wow, fantastic. And this equation is the equation of the circle expressed in standard. This is important, this name, standard form. Because we have another way. So this is a standard que is the most popular, is the most useful que we are using to describe the circle, no? Suppose, yeah, one elementary example to finish today. Suppose the example 1 for the circle part, example 1, in which everything is given. Write this equation. You need to find the equation. Write what? Write the standard form. Write the standard form. Of the equation of the circle, of the equation of circle, with the radio is equal 4, little r is equal 4, and center is located at the point 2, -4. Okay, this is easy, it's elementary. However, we have some detail. What is the detail? Look, we use one more time the formula. I want to copy. X minus h squared plus y minus k squared equal r squared. Okay. Who is h? Who is k? Who is r? Well, h is 2, k is -4, and r is 4. However, when you adaptate this parameter h, k, and r to the formula. Be careful, because it's h, x minus h. Pero who is h? 2. Ah, okay. Plus y minus, because the formula have a minus, pero k is -4. Entonces we have double negative. And double negative, you know, can become like a positive. So immediately, I directly, when you have practice, of course, you see, wow. Negative k and negative of the formula become positive. And in the right-hand side, we have radius squared. And the radius 4, therefore it's 4 squared. And 4 squared is 16. And this is my formula in the story. Okay? So be careful, be careful. I warning now, because in the test 2, of course, no test 1, no. In the test 2, we can see one question of this, of course, more complicated. This is too easy, in which you need to express it, or you write the equation for the circle in standard form. So be careful, okay, you know, the sign of the point and the sign of the equation are different. Okay, when it's positive, negative, when it's negative, positive, and don't forget get radius square. Okay, and this is the answer. Okay, guys, I suppose everything is okay for today. However, I want to record one more time that today is the due day for send me by email the answer for the test number 1. Okay, remember, guys, this is intensive course. This is a mini term. We are doing fast. We go moving fast. Okay, and don't forget also to submit your answer in the test number 1 online. And Alex, everything is clear? Everything is clear?
Yes, thank you.
Okay, thank you. Bye-bye.
Have a good day.
You too.